Only a few weeks to go here. We have a couple other techniques of integration that we're going to learn this week. We're going to do 7.2 and 7.3. I think the book assignment is going to be good enough. I don't think we need a quiz this week. So 2 assignments, no quiz. Post to the comments which ones you'd like to see me work out, and I can post some solutions by Friday. Okay, so here we go. Integration by parts. Let's start with an example. If I gave you x times e to the x dx, you're like, all right, well, I wonder if I can use substitution. Usually in this kind of a problem, we're letting u equal x, right? The exponent on the e. Well, that's not going to work in this case because the derivative of x is just 1. So that extra x out front is not going to get taken care of. So we're going to use this formula that says this. If I have some function u and a derivative of some other function dv, that integral equals u times v minus the integral of v times du. So it's just a formula we're going to follow. So the first thing we got to do is we have to choose our u and our dv. Okay, so I'm going to let u equal x, and I'm going to let dv equal e to the x dx. So the whole problem is represented, right? The whole thing is represented to the x e to the x dx. Now what I'm going to do is I'm going to find out what du is by taking the derivative. So derivative of x is just 1 dx. And then over here, since I started with dv and have to go backwards to v, I'm going to find the antiderivative. So the antiderivative of e to the x is simply e to the x. All right, so now here we go. I just use my formula. U is x, v is e to the x minus the integral of v, which is e to the x, du, which is dx. Now you can't have an integral in your answer, so we need to go one step further. So we're going to go x, e to the x, antiderivative of e to the x is e to the x, then plus c. So that is going to be integration by parts. Okay, so you're probably like, well, how do I know what to choose for u and for dv? So let's talk about that a little bit. So how to choose our u and our dv. So some bullet points here. Whatever you let dv be, you need to be able to find v. So you're going to need to choose dv so you can find its antiderivative. All right. It helps if u or du is simpler than u. Like 1, like the derivative of x is 1, that's simpler than x. And it also helps if v is simpler than dv. All right, let's do another one. How about if I give you this one? Theta cosine theta d theta. So helps if du is simpler than u. So why don't we try u equals theta. then du equals 1 d theta. And then let's do dv equals cos of theta d theta. So the antiderivative of cosine is sine. So here we go. My formula, u times v minus the integral of v times du. So theta sine theta minus the integral of sine theta, and then du is d theta. So I got to take it one step further, right? I can't leave the integral sign in my answer. So you get theta sine theta minus antiderivative sign, negative cosine. So minus a negative cosine, that's just a plus cosine. And if you took the derivative of that, right, you're going to end up getting theta cosine theta. Don't believe me? Here we go. So I could check my answer through differentiation. Products rule. First derivative of the second plus second derivative of the first. Derivative of cosine is negative sine. Derivative of a constant is 0. So those are gone. We got theta cosine of theta, which is what I was supposed to get. So I checked it and it worked. Let's do another one. What if I gave you integral of x to the third ln of x dx? So here's the rule of thumb to live by when you see ln's. So whenever there's an ln, we're going to let u equal ln of x. We wouldn't let dv equal ln of x because we don't know the antiderivative of ln of x. All right, so here we go. U equals ln of x. Du is 1 over x dx. dv equals x to the third dx. So v is the antiderivative of that, which is x to the 4 over 4. So here we go. U times v minus the integral of v times du. Alrighty. So I'm going to clean this thing up right here, this first term. I'm going to write it x to the 4 ln x over 4. Right here, I'm going to yank that 1/4 out to the front, right? So minus 1/4 integral, and check this out. X to the 4 over x, that reduces. That reduces to x to the third. Okay? Now the antiderivative of x to the third is easy enough. That's x to the 4 over 4. And I have a plus c chilling on the end. So that's going to be x to the 4 ln of x over 4 minus x to the 4 over 16 plus c. This is my final answer. All right, what if I give you something like this? You ready? So if I give you something like this one, the integral of x to the 4 times the sine of x dx. You're like, okay, well, 4x to the third, the exponent's smaller, so what if we try letting u equal x to the 4? Then du would be 4x to the third dx. And then if dv is going to be sine of x dx. So that's going to make v equal to negative cosine of x. All right, so now if we use the integration by parts formula, we got u times v minus the integral of v times du, which if I simplify that a little bit, we'd get negative x to the 4 cosine of x plus 4 times the integral of x to the 3rd cosine of x. So you look at that, you're like, oh man, what are you doing to us here? We're going to have to use parts again, aren't we? So, got to use parts again. Got to use that same formula, the uv times minus integral v du. Of course, so we'd have to do it for the x to the 3rd, then down to the x squared, then down to the x, then finally we'd have an answer at the end. Or we could do this alternate method. And this is usually a crowd favorite for students. And unfortunately, we're not there to enjoy it together. Alternate parts method. So this still is considered integration by parts, okay, everybody? It's still considered integration by parts, but we're going to call it the tabular method. It's just like a subset of integration by parts. So what we're going to do with the tabular method is we're going to make a table. We're going to have a sign column, S-I-G-N. We're going to have a U column where we're going to take the derivatives. And then we're going to have a dv column where we're going to take antiderivatives. And you're like, well, how do you know how big this table is going to be? Well, because my choice for u is going to be x to the 4th. Then I start finding derivatives of that. You got 4x to the 3rd. You got 12x squared. You got 24x. Then you got 24. And then you get 0. So anything past that, you're going to get 0 all the way down, right? The sign is just going to alternate starting with plus. So plus, minus, plus, minus, plus, minus. dv is going to be sine of x. We'll leave off the dx. And then we start taking antiderivative. So anti of sine is negative cosine. Anti of negative cosine, negative sine. Anti of negative sine, positive cosine. Anti of cosine, positive sine. And anti of sine, negative cosine again. All right, so you're like, hey, well, that was fun. Now what do we do? Here's what we're going to do. We're going to start with the first plus. We're going to go straight across and then go 1 down. So my first term is going to be x to the 4th times negative cosine of x. And then I'm going to go minus, because the next thing is minus, straight across and then down. So minus 4x to the 3rd times negative sine of x. Let's put the rest of my red arrows in here. Put the rest of my red arrows in. So the next term is going to be plus 12x squared times cosine of x, and minus 24x sine x, and then plus 24 times negative cosine of x plus c. All right, then we should clean that up because that's looking like not good. X to the 4th times negative cosine. Let's put the negative out front. All right, then this is going to be plus 4x to the 3rd sine x plus 12x squared cosine of x minus 24x sine x minus 24 cosine of x plus c. Final answer. Alrighty. Now, the tabular method does not work for ln problems. Works for any others except ln. So don't use tabular for the ln problems. Okay? Let's do one more. X squared times e to the 5x. So I wouldn't let u in my, let's use tabular again. So we got a sine column, a u column, dv column. I wouldn't use u equals e to the 5x because then du is 5e to the 5x, then 25e to the 5x, right? So I'm going to let u equal x squared. The whole point is this is going to zero out. So derivative of x squared, 2x. Derivative of 2x, 2. Derivative of 2, 0. So the sign, I got a plus, minus, plus, minus. dv is going to be e to the 5x. Now here's the deal on the 5, right? You think about it, we could use substitution to do this. Or we could accept this, that the integral of e to the kx is 1 over k e to the kx. Plus c. I need that 1 over k out there, so when I take the derivative to check my answer, it's going to swallow up the k that you get with the chain rule. All right, so antiderivative of e to the 5x, in other words, is 1/5 e to the 5x. Then that 1/5 times 1/5 e to the 5x is going to be the next one. So 1/25 e to the 5x. 1/25 times 1/5 e to the 5x, so 1/125 e to the 5x would be the next one. Okie dokie. So across, down, across, and down, across, and down. So here we go. I got x squared times 1/5 e to the 5x minus 2x times 1/25 e to the 5x plus 2 times 1/125 e to the 5x plus c. So let's clean it up. I'll put the coefficients out front. So 1/5 x squared e to the 5x minus 2/25 x e to the 5x plus 2/125 e to the 5x plus c. And there you have it, everybody. Integration by parts. So we'll have a few homework problems, and then we're going to go on to integration by tables, section 7.3. Like I said, I think these assignments are going to take you a little bit longer, so we'll skip the quiz this week. Maybe we'll have a bigger quiz next week on all the integration methods. That's it. Have a great day.